I'm going to be showing you how to make a TriggerBot for Assault Cube. This is going to be completely based on iPower's excellent text tutorial he made a couple years ago, and we're going to turn it into a video basically. Now what you're going to get is more practice with ReClass. You're going to learn how to use a ReClass generated class in your internal hack. We're going to get more practice reverse engineering, and we're going to learn how to call a function. All of our tutorials are meant to be done in a specific order. Each video builds on the concepts and techniques that you've learned in the previous videos, so it's very important that you do that. So the Start Here Beginner's Guide teaches you all the basics. So you should have already had done that, and you should have started the Beginner's Guide to Reverse Engineering. Our last video was the view matrix tutorial for CSGO, where we learned some stuff about that, and especially got some practice with ReClass. The other video we recently did was the entity list tutorial, which again is more ReClass experience. Now we're going to take that experience using ReClass and we're going to generate an actual class and actually use it in our hack. In the CSGO entity list video, we looped through the entity list using these generated classes. Now we're going to show you a little something different you can do with it. This tutorial is going to build off of our first internal hack source code. So you should have already done this video and you'll have the basics for an internal. We are basically going to edit the source code and we are going to add in our TriggerBot. Now do me a favor, people. I know how annoying the video intro is when I beg you to do the Start Here guide. I get it. But no one does it, and then they ask stupid questions. So until that ceases, I will continue to make those video intros. So we have our cheat table loaded up from the internal hack video, and we have some bots. If we look at this one, we'll see the name in the lower left-hand corner, Stephen Chapman. So the game, what it does is it takes your current position and your view angles, and it performs a translation across that axis of your view angles. So it goes from your current position towards infinity in the angle you're currently facing. That's what's called a ray trace function or a traceline function. And what it does is each iteration, it checks, have I collided with anything? If a collision occurs with a wall, then obviously it would stop doing the trace line. If it hits an entity, then it would return the address of that entity, which kind of acts like a handle to that entity. Once it does that, it displays the name on the screen. So that's what we're going to reverse. So first thing, we need to find out how that string gets set. So let's do a scan for Stephen Chapman as a string. And then let's look at the second character, Zelius, and we can see that the second variable changes. So we know this is the correct one, and we want to find out what writes to that string because we want to find that function which calls the traceline. So let's find out what writes to this address. We get our first instruction, go to the disassembler. Once we've got this in the disassembler, this is the instruction we're currently looking at. So it's move CL. CL is the lower 8 bits of ECX, so that's the first byte in ECX, and it moves it into EDX plus EAX. So what we want to do is, why don't we start at the top? So we're going to do select current function, and that's going to bring us to the top of the function. Let's set a breakpoint, and let's see what happens. So this is just some stack setup. If we look here, this instruction here, it's moving 109B74. That offset is for a local player. So EAX is now the local player object, and 10F4F4 is the offset for the entity list. You'll have found that out if you did our previous videos. And so our entity list is now in ECX. It looks like we're making space for some local variables with this sub ESP. We do a comparison against EAX plus 83. So EAX is our local objects, so 83 is a member variable for our entity, and it could be like a state variable or something like that. I think that's actually what it is. If we went into ReClass, we would easily figure that out. I'll show you that later. And then we're pushing some things onto the stack because maybe we're doing a function call, maybe we're preserving these arguments from the previous call, I don't know. Just keep scrolling down. ECX plus 82. You see, we're looking at a variable from EAX, which is our local object, and now we're looking at offset 82 from possibly the entity list. So these variables are both very close. I think these are both state variables, like alive or dead, something like that. We compare lower EAX with 5, compare it with 1. I'm not sure what that is. We see offset 338 here. Forget what that is. We can look at that later in ReClass. Trying to see what jumps out at me. I see a bunch of these OpenGL functions. Well, if this is the function that draws your HUD, right, your heads up display, right, your health and everything, and then the name, that would all get drawn in one call with your OpenGL function. So I think that's what we're looking at. If we keep scrolling down here, I'm just looking for things that jump out at me. Well, we see it's loading a HUD graphic for the damage icon, maybe. So that could be there. Basically, we're just getting an idea of what we're looking at. That's the first step, right? Now, if we keep scrolling, we finally see where it's accessing the name here. So the Zelia string is getting grabbed here, and it's getting moved into EDX. We then sub EDX from EDX. I don't know why it does that. Let's toggle the breakpoint here, and let's run until we break on it. So now we're looking at the Zelia string, is the address of that is getting moved into EDX. So EDX, once we step over this, is now the address of that string. If we look back at this real quick, 501C38, 501C38. So we're looking at the same thing. Now, EAX is this number, and EDX is this number. These are both pretty big numbers, and we're subtracting them. Why would we subtract the string variable from this random address? I don't know, so I'm just going to step over it. Then we're going to take EAX and move it into CL. So what is EDX? So let's open ReClass, and let's grab EAX. Let's put it in ReClass. Let's see what it could be. It's just the string Zelius. So we're taking the first byte in the Zelia string and we're moving it into CL, which is lower ECX. So let's step over that. And if we see now, lower ECX, that first byte on the right-hand side is 5A. What does 5A look like as an ASCII character? That's what I'm curious about. So browse this memory region. Now the Zelia string is down here, and we see the first byte is 5A. You can also see these little red arrows on the left-hand side. It's showing a loop. So what it's going to do is it's going to loop through that string, and it's going to copy, or maybe it does a comparison of all those characters. We see it moves CL into EDX plus EAX. Well, if we saw before, we subtracted EAX from EDX, and now we're adding them together. So we're basically just getting back to the EDX address, it looks like. And if we look here, I think that's what it's doing. Honestly, when you're reversing, you don't need to understand every instruction. Again, that instruction is not important. What I'm looking at right now is not important. I'm just trying to get a better idea of what's going on. If there's something interesting, I'll reverse every single instruction until I know it perfectly. For the sake of this, we're just looping through the string. EAX, we're incrementing it. So EAX is the address. It's kind of like the index of the string. So we're increasing it so that we can read the next byte. And we're just going to keep looping. And we're going to test lower ECX. So lower ECX, when that equals 0, that's our null terminator. So when we've reached the end of the string, the null terminator, test CL is going to be testing 0 against 0, right? And then the J and E, the jump if not equal, is then going to pass. So let's wait until we see it. Keep your eye up here and just keep stepping over until we see zeros, right? Now we have 0. And now it's gonna fail that jump, and it's just gonna continue. So now we're comparing another variable against 0. At this point, I'm not sure what it's doing. I do recognize this offset 374. That is the weapon variable. So why don't we get a better view of this by looking at this whole function in IDA Pro? So what we'll want to do is we'll want to get the address of this function. So we'll grab that. We've already done the disassembly for Assault Cube, and we'll press G to jump to address, and we'll drop that address in. So here we are looking at that same function, and we can just press F5, and that's going to decompile it. So it's a pretty big function. I see a lot of local arguments, local variables. I see it takes 4 arguments. It looks like IDA had no problem decompiling this. Nothing weird. All the OpenGL functions, again, we're definitely drawing the HUD here. Now what I'm looking for is the part where it's accessing this 225 offset to get the name string. So that's what we're looking for. I can say dword 50f4 effer. I know that's the local player. So let's rename this to local player. F4, F8 is the entity list, so we're going to rename that. Again, you'll have learned that in the previous video. Let's view these offsets in hex. So I have offset 338, 33C. I remember seeing that 338 earlier. Offset 82, we saw that too. 32C, I'm pretty sure that's the name variable. Now I want to see all these offsets in hex. So what we can do is change the default radix. So we go to plugins, X-rays, decompiler, options, and just change this to 16. And now we're going to see everything in hex. So we're looking for 225 again. And here it is. Okay, cool. So after all the OpenGL stuff is done, we call this function, which receives v15. v15 gets assigned to v16. If v15 is not null, then we access the name variable. So v15 is the entity whose name we're accessing, and we know that that entity is the person in our crosshair. So v15 is returned by this function. So I already think this is the GetCrossHairEnt function. So let's just go ahead and rename it. And let's jump into it and decompile it and just see what it does. So dword 509b74, this is just another offset for our local, it's another pointer to our local player. So let's just call that local player 2. We get, we see where it's accessing offset 83 again. So that's definitely an important offset. We're gonna look that up in ReClass later. So it gets this variable, puts it in v0, it checks if it's null, it checks if it's 2, and then it checks if 338 is not 1. And if this is true, then it gets set to 0, the result, and it returns the result down here. So if this variable 0 is no good, we return no entity. Otherwise, we're going to get a good entity, and we're going to return that here. So the result we're returning is the entity in the crosshair, and if it's not set to 0, then it gets it from this function. So this is the real getEntCrosshair function, and this is like a wrapper for it, okay? So let's just call this getCrosshairEnt2. So this function is getting fired off every frame, and I can almost guarantee you that this is like checking, is the player dead? Is the player alive? Is the player actually playing? And if they are, then call this function. So this is the real function that's doing the trace line. But of course, it's just another wrapper. I think the real function is one of these down here, but to us, it doesn't really matter. I can tell you looking at this that it looks like it's doing like a distance calculation, right? Whenever you see 4, 8, and C, and then no other offset, you know it's accessing a vec, right? It's the X, Y, and Z, either angles or coordinates, and then it's taking a variable, multiplying it by itself. It's squaring these variables, right? That's typical for a distance formula. And then v17 equals v16, and then this variable, this function gets called on v17. If we open v17, it returns the square root. So that is pretty sure that's a distance formula, right? Yeah, so I'll just drag this over real quick. What we're looking at is the distance formula. You subtract the source and the destination, and then you get the magnitude, which gets the square root of each variable, which is squared, and then added together. So it sums them and then calls square root. So we're definitely looking at some sort of traceline function, but we don't really care. None of this matters. We don't even need to call this function, which takes all these arguments. We only need to call one, because this function it doesn't take any arguments. It already knows where the local player is. You don't need to pass that. So we're just going to call this function getEntCrosshair, right? So if you look down here, the address of this function is 4607C0. So that's the function we're going to call. Besides just making a quick trigger bot, we also wanted to do one other thing, which is just use ReClass generated classes in this project. So let's do that now. Go over to GEngine. Let's grab this local player pointer. We'll take that address in ReClass, we'll paste it in, and what we're going to do is we're going to surround AC client, which is the module. We're going to surround it with angle brackets. That's going to get us the address of the module. Now this is a pointer, and we don't want the address of the pointer. We want the address of the entity it points to. So we're going to surround it with brackets. Let's add 2KB like we always do. And Here's the entity. We can see with RTTI, it is player ent, so we're in the right spot. I see a vec3 right here, the very obvious spot once you know what you're looking for. Here's another one, and here's another one. So these both look like position bars, right? Except one, the Z is slightly higher than the other one. So this is our head position, and this is our just regular position of our body, right? And then the Z is set to 0 here, so these are our angles, right? We could verify any of that by just going into Assault Cube, moving our mouse and jumping, right? So let's keep scrolling. I see 100, it could be health. I see in more hundreds, they could all be health. Having reversed this game many times, I know that this integer is health. So let's set that to int, and let's call that health. Let's keep scrolling. What else do we need for a TriggerBot? We have our position. We have our health. We need to be able to attack somehow. So we need a variable that's set to 1 when we're shooting and 0 when we're not. So you could search for that in Cheat Engine, but it's easier just to look in ReClass because we're pretty sure it's going to be in here, right? So let's just go to Cheat Engine, and we need to remove the breakpoint. And we need to run the game so it works correctly. Remove that breakpoint also. So now we're here, and we need to put ReClass right next to it, like so. And now we're just going to shoot, and we're going to look for changes, right? I do see a few things changing, but I'm just looking for a 1 and a 0. These are changing too much. They're not just 1s or 0s, you know? So let's keep looking. And this is weird, right? So I did find it. It's this first byte. If we shoot, that first byte gets set to 1 or 0, right? So it's actually right before our name string is 1 byte. We'll do it as an int 8. And this is our B attack. And if we set this to 1, will we shoot our gun? Yes. So we know we're good there. Put it back to 0. What else do we want to do? I want to show you the weapon, current weapon pointer. So if we keep scrolling down, we will see, I'm just going to move these over. And we see these heap pointers to objects on the heap, right? If we hover over them on the right-hand side, it's basically a display of that address dereferenced. So it's a knife weapon, it's a pistol, and a carbine, and a shotgun. So these are all weapon object pointers. Now, which one of these points to our current weapon? Well, we have the assault rifle right now. And let's actually go to our pistol. And we'll just look for the pistol, right? If you go through this whole list, I think if you get down to offset 374, we'll hover over it and it says pistol gun weapon. So this is our pointer to our current weapon. So we'll change the type, pointer. By the way, I'm using the latest version of ReClass.net, and I compiled it myself with all the latest comments, so it might be slightly different. If you're using ReClass.net with the latest version, you can't do like an int pointer. You can only do pointers to classes, so it's a little bit different. Once you get used to it, it's not really a big deal. It can be really annoying at first, but it's the way to go. So let's call this pointer. This is going to be called a current weapon. And let's just kind of see what we can do here. So the first variable is the V table, obviously. Now, if we go to the knife, that second variable is 0, assault rifle it's 6, pistol it's 1. So this is our weapon ID. This seems to be a pointer to the string for the name of the gun. If we look at this variable, it's a pointer to a player entity, and its address is 238A7D0. Well, our local player is 238A7D0, so this is the owner of the weapon. So again, we are going to change the type, and we are going to change the type to a pointer. And you know what we need to do? We need to name this object. So the current object we're dissecting is the entity, and then down here is the weapon. So we're going to rename this class to weapon. And this was a pointer to our owner. So we'll click these and select ent. So now this is our owner pointer, and it points to our entity, which is just what we're reversing right now. Let's take a look back at Assault Cube. We know we have 9 ammo in the mag and then 70 in reserve. So let's try to find those numbers. So if we hover over this variable, you see a 70. And if we hover over the second one, it's an 8. So these are both pointers to our ammo variables. Now, we can't use an int pointer in the latest version of ReClass. So what you want to do is make a pointer, and we want to point it at it's going to just be a new class, and we're just going to call it ammo pointer. We're going to have one variable in it, which is going to be an integer, and we're going to call it ammo. And then we're going to delete the rest. And this is going to be ammo reserve. And then the second one, it has 8, which is the ammo in the magazine. So we're going to change type again, pointer. We're going to change it to the ammo pointer type again. And then, so now we'll be able to access this, okay? Now, we're using a current weapon pointer, so we don't need to set these variables for every object. If we switch to the rifle, you'll now see 0 here, right? Because we're going to access that weapon. This is the best way to do this, rather than accessing the array of weapons and indexing to each of them and changing them as necessary, right? So now we can change that. You know what the last variable we need is? We need the team variable to make sure we don't shoot our teammates and that we're only shooting enemies. So let's look for that. So the team variable is either going to be 0 or 1 depending on the team. So again, we just look at ReClass and then we change teams. So I see a 1 and I hit change teams, or maybe not, and now I have a 0. I'm going to change team again and I see a 1. So this variable is our team, offset 32C. There might be other variables which do similar things. I think it was this variable was also a 1 or a 0, but now it's -4. So we know that's not it. Easy. So I think we're good there. Once I have everything I want, I right click over here, remove unused classes to tidy it up, and then I generate C++ code. So now we get this, right? So we can then copy and paste this into our Visual Studio project. So we're going to extract our source code from the previous tutorial, and let's open up that source file. We're going to modify it with our ReClass file and add in a TriggerBot. So first we want to do is let's just open these files and see what we're looking at. Let's add a new file, new item, and let's just call it ent.h, and that's going to have our entity thing from ReClass. So generate C++ code, copy and paste all of it. And we're going to need to include a few things. Include windows.h, right? CSTIO and CSTDINT, so we can access those fancy integers. Now, we see vector3 isn't defined, so let's do struct vec3 float xyz. Everyone should know what that's about now. And in your source code, oftentimes you're going to have conflicting versions for vec3 and vector3. So what I like to do is I like to use using vector3 equals vec3. So now I can use my source code, which uses vec3. I can use ReClass classes, and I don't need to go and do find and replaces on all the variable names, right? And let's scroll down. We see these static asserts are failing. This is something new. I think they only do this in the latest version of Visual C++ 2017 ISO standards. So what we want to do is go into the C++ and project properties, go to all options, and look for, forget what it's called, something standard. Yes, C++ language standard, and we're going to set it to C++ 17 standard. So now that should compile now until IntelliSense warnings went away. Now you can just delete these too. Basically the purpose of this in the latest version of ReClass is to make sure that your compiler settings are set to use the same data type sizes that ReClass generates. So let's say your compiler had a different variable size for int32t. It never would. because that's a specific type of variable to mitigate this exact problem. But let's say it does, then you're going to have a problem. So if static assert fails, it won't let you compile. It's going to tell you there's a problem. So if this is an issue for you for some reason, you can just delete those. But it works. We have it set up right, so we're good. Let's go back to DL main, and we just want to delete everything and just clean it up because we don't need any of this crap anymore. I had two different ways to get the module pointer. We don't need them both. We can delete that. We can get rid of all these stupid comments. And so what do we need to do? First one we want to do is convert everything over to using the ReClass methods, okay? So if we see here, we get the module plus the offset to get our local player pointer, and we're using uint pointer. This is like a scheme you would use if you were external. Now that we're internal and we have ReClass files, we don't need to do that. Same thing with ReClass. We don't really need find DMA addy anymore. We're going to just access these instructions as we need them. So the first thing that we're going to do is we're going to define this local player pointer up top, and we're going to define it as ent pointer local player pointer, and we're going to initialize it to null pointer. And it does not like that because we need to include the header. So now we have a variable that is null, and we're going to check it down here, right? Because we don't want to dereference it and crash the game. We have turned this into an ent pointer, but we've already defined it at the top, so we no longer need that. So we got local player pointer, and we're going to set it to this address, except it's not an address, it's an ent pointer. So this address is the address of the pointer. We want our new pointer to point at the actual address of the object. So to do that, we need another level of dereference. So we're going to do it like this. So this takes the address of the entity pointer, and it casts it to an entity pointer to a pointer. And then we're going to dereference that, and we're going to get the address of the actual object. So our new local player pointer is going to point at the actual object itself, not this pointer. You get it? So we're going to check if it's null, and because we don't want to access any improper memory unless it is a real variable. When you're not in a game, let's say you're in the lobby, this will be 0 in most games. Assault Cube and CSGO, that's accurate. Now, we no longer need to cast all these things to ints and do it like this. So I'm going to show you the best way to do it. So we're going to do local player pointer health equals 1337. That looks a lot cleaner, doesn't it? This is the beauty of using ReClass. Same thing. Look at all this just to change the ammo for the weapon, right? Now we're going to do local player pointer weapon. Did we? Hey, we didn't do that correctly. Let's go back to ReClass and let's open this weapon. And yeah, I didn't name this. So this is called ammo clip. So let's regenerate, copy that, go over to our entity. Now let's go back to here and ammo clip and set that to 1337. And now we can delete all of this, but it's not working. What did we do? All right, so we got a warning here. What did we do wrong? I think we forgot something. Yeah, see, this variable isn't done correctly. ReClass. Let's go back to weapon. This is going to be called ammo clip. Now it's probably properly defined. Let's export this class again. Let's go back to our ent header, and we'll just replace this. Now, this will get us access the ammo clip. Ammo. There we go. Now we're good. Compiles. Yes, thank you, Jesus. Okay. Next, we need to do our TriggerBot. So, first we need a hotkey. So, actually just copy this thing. Change the numpad to 3. And we need a bool for B TriggerBot. Then we got to add one up here. Set it to false. So now we got the hotkey, and now we need the trigger bar. So if our local player pointer is good, we will set the hacks, and now we want to do our trigger bot now here. So if trigger bot, we want to get the crosshair entity, so we're going to do ent pointer crosshair ent, and we're going to set it to the null pointer. And we need to put in that function, don't we? So let's go back to IDA Pro, and it's going to be int get crosshair entity, and the address was 4607C0. So let's go up into our global namespace here, and let's create a function pointer. And so how we're going to do that? We're going to do that with a type def. We're going to do type def ent pointer, and it's a cdecl function. So how do we know it's cdecl? Well, IDA Pro doesn't give us any different calling convention type, so the default is always cdecl. Now, how can we tell if it's cdecl? Basically, anytime a function is called, you have the caller, which is the function that calls the function, and then you have the callee, which is the function that's being called. So in the case of cdecl, the caller cleans up the stack, and memory addresses are returned in EAX. So let's see if this is a cdecl function. Let's go to GEngine. Let's go to the address of the GetCrossHairEntity function, and let's right-click it and do select current function. We're going to go down to the return. We're going to set a breakpoint, and we're going to run it. So now we are broken at the breakpoint, and we want to look at what is in EAX. So EAX is DE74018. So let's look at that. Let's grab that address. That should be the address of the entity that we're pointing at. Let's go to ReClass again. New entity, paste that in, add a bunch of bytes, and let's scroll down until we see a name. We see the name here is Christy Vlad, and if we turn off the breakpoint, run it, and then select GEngine, we were just looking at Christy Vlad, right? So we know it's passing the return in EAX. Now, which is interesting, this function, it has no arguments. If this function had arguments, you would be able to tell in which order they are pushed onto the stack, and maybe if they're passed in different registers, you might be able to discover the different calling convention based on that, but there's no arguments. In addition to the function not having any arguments, there's no kind of like stack cleanup, because there's no arguments that need to be popped back off the stack once it returns, right? If we go to the return, and then we step into it, we're now back in the caller right after the call itself. So you see there's no cleanup happening here, and that's because there's no arguments. All right, back to our coding. Okay, so it's a cdecl pointer, and we're going to call it t get crosshair ent. That's just a naming scheme. A T is like for template. And then we're going to do t get crosshair ent, get crosshair ent. So we're going to make a pointer, a function pointer out of that template called get crosshair ent, and we're going to make it point at nothing. And we're going to get its address after the module is located. So once the module is found, we know that we can get that the function will be loaded, and we can get the address. So now we're going to assign its address. Get crosshair ent equals t get crosshair ent module base plus 0x607c0, which is just the address we got before, but it's in the format of this. Looks like I didn't spell this correctly. Okay, there we go. So basically, we've created a function pointer of a type def for one, and then we're using that type def to create a function pointer called getCrosshairEnt. Assigning it to 0. Once the game is loaded, we cast the address of the function to its function pointer. So now we can call that function just as if we were the game. This is where ReClass plus calling functions, the real beauty of internals, comes into play. So let's go back down to be crosshairEnt, and let's do crosshair ent equals get crosshair ent. So now we're just simply calling the function. And you know what? We don't even need this line here, we can do this. Because crosshair ent is null if this returns 0, basically. If no entity is collided, then it just returns 0. So that's perfect. We don't need the null pointer there. So now we do if crosshair ent. If it's non-zero, do another statement. We want to check the crosshair ent's team. So we're going to do if local player pointer team does not equal crosshair ent team. Bro, can you spell, man? Holy shit. Okay. Local player pointer the attack equals 1, right? We're going to set that attack variable to 1. And if there is no entity in the crosshair, we're going to want to set it to 0, right? Oops, else. Local player pointer the attack equals 0. All right, that should work. Let's compile it. And let's just talk about this real quick, right? If the TriggerBot is turned on by our hotkey, we'll call the GetCrossHairEntity function. It will get the entity pointer. If the entity pointer is non-zero, we will then compare its team against ours. If they are not on our team, we will shoot. If they are on our team, or the crosshair ent is 0, then we will not shoot, right? If you don't do this, it sets it to shooting constantly, and you'll shoot your whole clip even if the guy's dead or you stop looking at him. So that's why we do have this if statement setting it to either true or false. So let's get this thing going. Let's run the debugger. I just realized one little issue we had. What the hell is that? Visual Studio is a nightmare sometimes. I actually used this hotkey twice. So numpad 3 is for TriggerBot. Numpad 4 is going to be for no recoil. And so now we can compile. Go to our injector, inject, numpad 1, 2, 3, and 4. We should now have unlimited ammo, health, and no recoil. If we look at one of our teammates, nothing happens. And then let's find some enemies, and the TriggerBot will activate it itself, and it will shut itself off. So there you have it, TriggerBot working. Ray can't get up a ladder because he's an idiot, apparently. Do you know what the best thing you can do with a fully functioning TriggerBot? You can go over to guidedhacking.com/donate and you can donate to get more videos like this made. Thank you for watching, and please, for the love of God, do the start here guide.